Good afternoon. Today we will see about the superposition theorem. We will wait for 1 minute for other students. Up to that, we will revise our previous session and then we will start our today's session. In previous session, we have studied about Kirchhoff current, Kirchhoff voltage law, node analysis, mesh analysis, source transformation, and the source shifting. So Kirchhoff current's law, it states that at any incoming node, the current will be equal to the current incoming is equal to the current outgoing at that node. It means what? Algebraic summation of current at any node will be 0. Incoming current at the node will be equal to outgoing current at that node. Node means if at any point in the circuit two or more than two elements are connected, then we are calling this point as a node. Then KVL. KVL states that algebraic summation of a voltage or a potential difference across all the elements in a closed loop will be 0. मतलब हमारे पास यदि क्लोज लूप है तो क्लोज लूप में जितना पोटेंशियल डिफरेंस रहेगा उसका समेशन. Summation means what? If we will take the directions according to the divider rule, it means what? Current is moving from higher potential to the negative potential. It is nothing but lower potential according to the sign convention. If there is a potential rise, it means what? If it is taking potential, then we are taking it is positive, and if it is giving potential, then we are calling it is a potential rise. मतलब वो पोटेंशियल दे रहा है तो वो पोटेंशियल ड्रॉप हो जाएगा, एंड इफ इट इज टेकिंग सम अमाउंट ऑफ वोल्टेज देन वी कैन कॉल इट इज द पोटेंशियल ड्रॉप. So then we have seen about the node analysis. Node analysis is also called as a node voltage method. In this method, we are considering one node as a reference node. We are considering the voltage across that node is 0, and we are calculating the voltage of remaining node by using KCL law. मतलब हम नोड एनालिसिस में KCL यूज कर रहे हैं और अननोन वोल्टेज डिराइव करते हैं. Then we have seen about the mesh analysis. Mesh analysis is used to calculate the value of unknown voltage, unknown current. Sorry, unknown voltage हम node analysis से निकालते हैं by using KCL. और हम इसमें क्या करते हैं? mesh analysis में we can derive unknown value of current by using the KVL. And if there is a known value of current is in between closed loop, then we are calling this circuit as a super mesh. And we cannot apply KVL directly. We have to write the equation according to that value of current for this super mesh, and we can apply KVL to the remaining nodes. Today we will see about the superposition theorem. Superposition theorem extends the use of Ohm's law to circuit with multiple sources. According to superposition theorem law, we can derive the value of unknown voltage or unknown current. But this superposition theorem can be used only for linear and a bilateral network. If you see, सुपरपोजिशन थ्योरम हम लीनियर और बायलैटरल नेटवर्क को ही अप्लाई कर सकते हैं. वी कैन नॉट अप्लाई सुपरपोजिशन थ्योरम टू द नॉन लीनियर सर्किट्स. After completion of first unit, I will give you one test, unit test 1, and this test will have MCQs question. At that time, ये जो है small basic concepts, मतलब सुपरपोजिशन थ्योरम कौन से नेटवर्क के लिए अप्लाई कर सकते हैं, नॉन लीनियर के लिए कर सकते हैं या नहीं, मेश एनालिसिस सुपर मेश में क्या डिफरेंस है, दिस थिंग्स विल बी नीडेड टू सॉल्व द एमसीक्यूज. दैट्स व्हाई जस्ट पे अटेंशन और अच्छी से ध्यान दो, मैं क्या बोल रही हूँ उसको समझ के लो. सो सुपरपोजिशन थ्योरम, इफ इन एनी इलेक्ट्रिक नेटवर्क it contains two or more than two network, then we can use superposition theorem and we can calculate the current passing through any resistor, because here the current passing through any resistor is the combined effect of all energy sources. मतलब हमारे पास यदि कोई सर्किट है तो हम क्या कर रहे हैं वहाँ का, यदि हमें वहाँ का वोल्टेज या करंट फाइंड करना है और वहाँ पे यदि दो से ज़्यादा बैटरी या फिर दो से ज़्यादा करंट दिए हुए हैं, तो हम क्या कर सकते हैं, कोई भी रजिस्टर में से जो करंट जाएगा वो दोनों वो वोल्टेज वो दोनों बैटरी या दोनों करंट की वजह से जाएगा। तो हमें क्या करना है, वहाँ जो वो रजिस्टर में से जो करंट फ्लो हो रहा है, that current will be combined effect of these sources. So we have to derive the value of current flowing through that resistor, or we have to derive please mute yourself Pranali, or we have to derive the voltage across that resistor. We can derive by using the superposition theorem. We can derive the combined effect of batteries or a current source to derive the value of unknown current flowing through or the value of voltage across that element. What we have to do in superposition theorem, we will see. So, superposition theorem is very helpful in determining the voltage across any element or a current flowing through branch when the circuit contains more than one element. It is nothing but the circuit contains more number of voltage source or a more number of current source. So, we can solve that circuit, we can derive the value of unknown current or unknown voltage by using superposition theorem. While using superposition theorem, only one source can be considered at a time. मतलब हमारे पास यदि दो से ज़्यादा करंट सोर्स या फिर वोल्टेज सोर्स दिए हैं और हमें सुपरपोजिशन थ्योरम यूज करना है और किसी रजिस्टर के थ्रू जाने वाला करंट डिराइव करना है या फिर किसी रजिस्टर के अक्रॉस का वोल्टेज डिराइव करना है, तो हम वो कैसे करेंगे, वी विल कंसीडर वन वोल्टेज एट अ टाइम एंड वी विल नॉट कंसीडर रिमेनिंग एनर्जी सोर्सेज, या फिर वोल्टेज या करंट जो भी बाकी दिए हैं वी विल नॉट कंसीडर. सो व्हाट वी विल डू, we have to short or open that circuit. We will see how we will short and open and which component will be shorted and which component will be open. So these are some steps given to solve the superposition theorem. If we have to apply superposition theorem, then there are some conditions which needed to follow. The all components needed linear or a bilateral. Linear means what? If current is proportional to the applied voltage or flux is proportional to the current. That is not, that means what? जो वैल्यू है वोल्टेज या करंट सोर्स का, दैट विल बी प्रोपोर्शनल विथ, यदि वोल्टेज है तो करंट के साथ प्रोपोर्शनल रहेगा या फिर करंट है तो वोल्टेज के साथ, एंड दिस प्रोपोर्शनल विल बी लीनियर, मतलब जितना वोल्टेज में चेंज हो रहा है उतना ही करंट में चेंज होगा. And all components needed bilateral. Bilateral means meaning that current is the same amount for opposite polarities of the source voltage. Means जितना वोल्टेज है उसके opposite polarities में current same amount है. So we can say these components are a bilateral. And in that circuit, passive components may be used. Passive means what? We can use resistor, capacitor and the inductor. We cannot amplify or rectify the value of energy sources. So we have to use only passive components. If there are not active components, it means what? The components which can amplify or control the value of voltage or a source, these components cannot be used in superposition theorem. And the active components, if you see, transistors, semiconductor diodes, electron tubes, these components are neither bilateral or not a seldom linear. So we cannot use these active components in a superposition theorem. Now we will see how we have to solve circuits containing only independent sources. So what does mean by independent? If the value of voltage source or a current source do not depend on any other voltage or current, then we can call these sources as a independent sources. So we have to consider only one source active at a time, and we have to remove all the ideal voltage sources and current sources. If there is a voltage source, then we can remove ideal voltage source by short circuit. And if there is a current source, then we can remove ideal current source by the open circuit. हमको क्या करना है, एक वोल्टेज या फिर एक ही करंट को एट ए टाइम कंसीडर करना है. We have to consider only one source active at a time, and we have to remove remaining sources. If there are current source, lots of current source, then only we have to consider one current source active and remaining current source will be open. ये हम ऐसे उसको ओपन सर्किट, क्योंकि ओपन में से जो यहाँ पे ओपन है तो करंट विल नॉट फ्लो, और वोल्टेज यदि पैरेलल है तो वैल्यू क्या रहेगा, will remains constant. ये जो voltage है उतना ही. That's why we have to remove remaining voltage source by the short circuit. If there are practical voltage sources, replace them by combination of ideal source and the internal resistance. And we have seen in a source transformation in yesterday's session, we have seen how to convert source into a voltage source into current source and current source into a voltage source. हम क्या करते हैं, voltage source को हम सीरीज में एक रेजिस्टर देते हैं, और करंट सोर्स है तो हम क्या करते हैं, उसके प्रैक्टिकल में एक इंटरनल रेजिस्टेंस लेते हैं. बट हमें क्या करना है, एक ही कंपोनेंट, एक ही एलिमेंट, एक ही एनर्जी सोर्स वी हैव टू कंसीडर एक्टिव, और रिमेनिंग को क्या करना है, रिमूव करना है, और करंट सोर्स को हमको ओपन करना है. तो व्हाट वी विल डू if we are having that circuit current source where resistance is in parallel, we will open that current, and that resistance we will take here one internal resistance, and that resistance will be in parallel with current. But here we take this current as the open circuit. And if there is an ideal voltage source, there is a practical voltage source, sorry, if ideal, then there is no need, we can do short, we can directly replace voltage source by short circuit. But if there is a practical voltage source, then we can take one additional resistance with this voltage source. But we know if doing we are using superposition theorem to calculate value of unknown sources, then we have to remove remaining voltage sources. We have to remove remaining voltage sources by using short circuit. That's why we have to use short circuit instead of this voltage. और करंट है तो करंट को हम क्या करेंगे, ओपन करेंगे. Now we will see one example. If you guys see, this is the circuit diagram where two voltage supplies are given. There is one resistor is given. What we have to do? We have to find the current flowing through this resistor by using superposition theorem. So what we will do? We will consider only one voltage source at a time. And what we will do? Other voltage source we will take as a short circuit. So firstly, we will short circuit voltage source V2. ये V2 को मैंने क्या किया है, शॉर्ट कर दिया है. And what I am trying to do here, I am trying to calculate the value of current flowing through this resistor just because of this voltage source. उसके बाद मेरा सेकेंड प्रोसेस क्या रहेगा, मैं इसको शॉर्ट कर दूंगी और इस रेजिस्टर में से जो करंट जा रहा है ये वोल्टेज की वजह से वो फाइंड करूंगी, एंड देन आई विल टेक द समेशन ऑफ दिस करंट, देन आई विल गेट द वैल्यू ऑफ करंट फ्लोइंग थ्रू दिस रेजिस्टर. So our first step is here. We have to short the voltage source V2 and we have to calculate current flowing through this resistor. If you guys see Here only one voltage source, one resistor. So according to Ohm's law, we can calculate I equal to V by R. As this is the V1, this is the one resistor, we can take here I1. I1 equal to V1 by R. यहाँ पे तुमको इनके वैल्यूज दिए हुए होंगे, 2 वोल्ट, 5 वोल्ट, किलो एक ओहम या किलो ओहम में रजिस्टर का वैल्यू। तुम्हें क्या करना है, वो वैल्यूज यहाँ पे रखना है। यू विल गेट द वैल्यू ऑफ करंट I1. Our next step will be to short the V1. Short the circuit voltage V1 and finding the voltage I2 flowing because of the voltage source V2. According to Ohm's law, we will get I2 equal to V2 by R. But as this is the positive to negative, we are taking from this direction clockwise in opposite, और ये resistor positive to negative this side रहेगा. That's why we are taking here negative sign. So I2 will be minus V2 by R. We will get the value of I2 and I1 here. So net current will be, ये जो circuit है, net current will be addition of these two, I1 plus I2. We will get the value of total value. So we will get V1 by R minus V2 by R. If you see, these are having, if you are taking clockwise directions, तो इसका और इसका directions oppose हो जाएगा, because we are considering from firstly we will short the V2, तो हम ऐसे डायरेक्शन लेंगे. इन नेक्स्ट स्टेप व्हाट वी आर डूइंग, वी आर शॉर्टिंग दिस V1 और हम ऐसे डायरेक्शंस ले रहे हैं क्लॉकवाइज, तो निगेटिव से पॉजिटिव जा रहा है. दैट्स व्हाई वी विल टेक हियर negative. So we will get I equal to I1 plus I2, and this is the correct answer. This is the net current we will get, which is flowing through resistor R, and we can calculate the value of current by using superposition theorem. We can use another method. Same answer is obtained by using another method. As you know here, if you see this example, we have to calculate the value of voltage here. If there are two voltage sources, if you are taking clockwise directions, then you guys can see here, this is from positive to negative, but it is V2 is from negative to positive. ये यहाँ से negative से positive की तरफ. That's why we can calculate VR equal to V1 minus V2. And according to Ohm's law, we can write V1 equal to, we can write here V1 equal to I by R and V2 equal to I2 by R, I1 by R. So if you calculate the value of VR here, you know I equal to VR by R. So you will get the value of current I equal to V1 by R minus V2 by R. Both are same equations, so you can cross verify according to superpositions. You are getting correct answer or not. तुम्हें यदि एग्जाम में क्वेश्चन है, तुमको यदि अननोन वोल्टेज या करंट डिराइव करना है बाय एनी मेथड, तुमको जो मेथड सिंपल लगता है वो मेथड से तुम उसका आंसर क्रॉस वेरीफाई कर सकते हो. बट तुम्हें यदि बोला है सुपरपोजिशन से, देन यू विल गेट आंसर ओनली यू if you are solving the answer by, you are solving the question by using given method. तुम सिर्फ क्रॉस वेरिफिकेशन के लिए दूसरा मेथड यूज करके देख सकते हो कि आंसर करेक्ट आ रहा है या नहीं. नाउ वी विल सी अनदर वन एग्जांपल. Here 3 resistors and 2 voltages are given. All are having the values. Resistor का values दिया है, voltages का values दिया है. What we have to do? We have to calculate the value of current by using, we have to solve this circuit by using superposition theorem, and we have to calculate the value of current flowing through this resistor IR3. ये दोनों का जो बीच का है रेजिस्टर है, ये दोनों लूप के बीच में जो रेजिस्टर, वहां का हमको करंट ड्रॉ करना है. करंट कैसे डिराइव करेंगे? करंट इज फ्लोइंग थ्रू, नॉट अक्रॉस. वोल्टेज हम अक्रॉस में मेजर करते हैं, करंट हम कैसे, वो वो कंपोनेंट के बीच से जो करंट जा रहा है. what we will do, we will use here superposition theorem. According to superposition theorem, firstly we have to consider only one voltage and we have to remove remaining voltage. As here is a voltage source, we have to short this voltage. Firstly, we will consider V1, we will short V2. Then what we do? We can see here, these resistors are connected in parallel. So we can calculate the R equivalent. How will you calculate? R2 and R3 parallel hai. If two resistors are parallel, then 1 upon R equivalent to 1 upon R2 plus 1 upon R3. Then you will get R2 plus R3 upon R2 into R3. और तुमको वो 1 upon R equivalent मिल रहा है, तुमको R equivalent करना है, तो तुमको कैसे मिलेगा? R2 into R3 upon R2 plus R3. वो जो वैल्यू रहेगी, if you see ये दोनों का R equivalent मिलेगा, that will be in series with this R1 resistor. तो इसका जो वैल्यू रहेगा, you will take this value in series with R1 and you will add that value with 100 ohm. Then you will get R equivalent equal to 106.7 ohm. मैंने यहाँ पे directly answer लिखा है. You guys can solve. I will share these PPTs and also this my लाइव सेशन ऑन यूट्यूब. मैं क्लासरूम में उनकी लिंक शेयर कर रही हूँ, तो वहाँ पे जाके एग्जाम्पल लेके खुद सॉल्व करके देख सकते हो. How we have to solve? We have to calculate R equivalent. Firstly, these two are in parallel. Then the value of this RP will be in series with R1, and you can call this value as a R equivalent. Then what we have to do? We have to use Ohm's law. According to Ohm's law, you will get the value of current here. ये IT, ये जो पूरा करंट जा रहा है, you will get how? V1 upon R equivalent. V1 का वैल्यू है 15. 15 upon 106.7. You will get the value of IT is 0.141 ampere. What we have to do? We have to calculate the value of IR3. You can solve this value of IR3 by using any method. तुम यहाँ पे क्या कर सकते हो? You are getting the total current, यहाँ पे मिल रहा है. तुम यदि इसके बाद यदि ये शॉर्ट करोगे और इसको कंसीडर करोगे, तुमको यहाँ इसकी वजह से जो करंट जाएगा उसका वैल्यू मिल जाएगा. You guys can see. Next, if you are considering V2 and you are doing short circuit of this V1, you can see 110 ohm, these are in parallel. You can calculate 1 upon 100, 1 upon R1. That will be 1 upon R equivalent. उनका रेसिप्रोकल लोगे, you will get the RP value. इन दोनों का parallel equivalent resistance. And this resistance will be in series with this 220 ohm. If you calculate the value, ये इन दोनों का जो RP मिल रहा है, उसके साथ 20 ऐड करोगे, तो तुमको ये R equivalent का वैल्यू मिलेगा. So अभी हमारा सर्किट कैसे बनेगा? ये वोल्टेज और उसके साथ R equivalent रेजिस्टर रहेगा. That will be in series. If you solve according to Ohm's law, V2 equal to IT into R. तुमको I का वैल्यू यहाँ पे V2 का है, तुमको R equivalent मिल रहा है, तो तुमको I का वैल्यू मिल जाएगा. You are getting this voltage, this current जो इसकी वजह से जा रहा है. You are getting the value of current which is flowing through V1 also. Then you can calculate the value of IR, and that value will be for V1 you will get the value as a 0.094 ampere, and if you solve for the V2 you will get this value as a 0.406 ampere. Then what we will do here? You can see here, as we are getting here IR3 when V2 is shortcut, and when we are getting value of current when we are considering only V2 और V1 को जब शॉर्ट कर रहे हैं. Adding these currents, ये दोनों का डायरेक्शन सेम है. If you see this node, यहाँ पे भी पॉजिटिव है वोल्टेज का टर्मिनल, यहाँ पे भी पॉजिटिव है. These are the incoming. So what we have to do? We have to take here addition. If you do addition of these two currents, you will get IR3 will be 0.5 ampere. If you are taking the addition of these two current. और यदि एक बैटरी इसके ऑपोजिट रहता है, तो जो ज्यादा रहेगा उसमें से कम जो रहेगा, what we have to do? We have to do subtraction. But both are having the same direction, so we are taking the additions of the current. And what we are doing here? Firstly, we are considering only V1. We are doing short circuit of V2. Then we are calculating current flowing because of a V1. Then we are considering only V2 as a voltage source and we are taking V1 as a short circuit. Then we are calculating current flowing through this resistor because of V2 source. And then we are taking the addition of these two currents. We will get the value of current flowing through R3 resistor by using the superposition theorem. Again, we will see one another. This is the This is the same example I have given here, only explanation. With zero point 0.5 ampere flowing in R3, voltage across R3 must be 5 volt according to the Ohm's law. And as we know the KVL, voltage across R1 must be 10 volt and voltage across R2 must be 8 volts. Solving these currents, you will get the value of current flowing through R1, R2 also. According to KCL, R3 का पता है तुमको, तो you will get the value of IR1 and IR2 because तुमको यहाँ के resistors के value पता है. You will get the value of IR1, IR2 and IR3 also. You will get IR3 as a 0.5 ampere. So how we are solving? We are using superposition theorem where circuits are having independent or a dependent source. But only we are using superposition theorem for linear and bilateral network. We cannot use superposition theorem for a non-linear network. We have to consider only one source to be active at a time. We have to remove remaining sources. If there are independent voltage sources, then we have to remove these sources by short circuit. And if there are ideal independent current sources, then we can remove this circuit by a open circuit. But neither short circuit nor open circuit the dependent source. We can do this for only the independent sources. Leave them intact as they are. यदि डिपेंडेंट है तो वो जैसा है उसका वैल्यू हम वैसे ही रखें. Procedure for applying superposition theorem. A voltage source whose parameters are controlled by voltage or current. These formulas you don't need. You will need only how we are taking the voltage source and current source dependent. If any voltage source is depending on other voltage source, we are calling this as a voltage dependent. If the value of voltage source is depending on other current source, then we can call this circuit as a current dependent sources, and we are using these procedures to apply superposition theorem. And if there is a dependent current source and its value is depending on a voltage, then we can call this as a voltage dependent current source. And if the value of dependent current source is depending on other current source, then we can call this as a current dependent current source. It means what? यहाँ पे यदि हमारे पास डिपेंडेंट सर्किट है तो हम उसको रिमूव नहीं कर सकते. वी हैव टू कीप दिस सर्किट एज इट इज. बट इंडिपेंडेंट है वी कैन रिमूव. वोल्टेज सोर्स हम कैसे रिमूव करेंगे? बाय यूजिंग शॉर्ट सर्किट. एंड वी कैन रिमूव current source by using open circuit. Again, we will see one example. What we have to do? Find the value of IO, output current, in the circuit shown below. The circuit involves dependent source. So we have to consider this as it is. The current may be obtained by using superposition as. It means what? We have to calculate the value of output current by using the superposition theorem. If you see, these are the dependent, but यहाँ पे जो है, these are not dependent, these are the independent. So we can remove by using voltage source, by using short circuit, and we can remove current source by open circuit. So To obtain the value of output current, firstly we are considering only 20 volt source. हम क्या कर रहे हैं यहाँ पे, जो 20 वोल्ट सोर्स है उसको हम शॉर्ट कर रहे हैं एंड वी आर कंसिडरिंग ओनली लूप 1. ये जो 4 एम्पियर है, यहाँ जो करंट जा रहा है, वी विल, ये जो सर्किट है, फर्स्टली सी, यहाँ पे एक दो वोल्टेज सोर्स दिए हैं, यहाँ पे करंट सोर्स दिया है एंड दीज आर नथिंग बट इंडिपेंडेंट. तो व्हाट वी कैन डू, वी कैन रिमूव. पहले हम इसको कंसीडर कर रहे हैं और 20 वोल्ट को हम क्या करेंगे, शॉर्ट कर देंगे. तो फर्स्ट लूप के लिए हम कैलकुलेट कर सकते हैं. इफ यू सी इन फर्स्ट लूप we have known the value of current का वैल्यू डायरेक्टली पता है. there is no need to use KVL KCL, we can directly write. हमने लास्ट कल के सेशन में देखा है मेश एनालिसिस में, यदि हमको करंट का वैल्यू पता है तो हम डायरेक्टली लिखेंगे. तो हम क्या लिख रहे हैं यहाँ पे, I1 इक्वल टू 4 एम्पियर. देन फॉर लूप 2 we can write the equation here. In 2 ohm only I2 is flowing, but in 1 ohm, ये जो वहाँ पे ये जो 1 ohm है, I2 is flowing also, I3 is, but I2 is in incoming, but I3 is outgoing. That's why we are taking here I3 negative. And if you see about this 3 ohm, यहाँ का I2 is यहाँ से जा रहा है, but what happened here, I1 is, ये I1 का डायरेक्शन ऑपोजिट है, ये इनकमिंग है बट ये आउटगोइंग है. सो वी आर टेकिंग I2 एज अ पॉजिटिव एंड I1 एज अ नेगेटिव. these equations we will get by solving KCL for this loop. से फर्स्ट लूप के लिए KCL अप्लाई करना का जरूरत नहीं है बिकॉज वी हैव द वैल्यू ऑफ करंट हियर. फॉर लूप 3 थर्ड करंट वी आर कंसिडरिंग हियर शॉर्ट सर्किट. व्हाट वी विल डू, I1 ये जो 1 ओहम है उसमें से, if you see here in 1 ohm I3 is going also out, I2 is, I2 जो है outgoing है, so we are taking as a negative and I3 is a incoming, ये 1 ohm के पास clockwise, so we are taking it is a positive. if you see about this 5, ये 5 ohm के लिए, ये 5 ohm, what we are doing here, you can see here I3 is incoming but I1 is outgoing, so I3 minus I1 5 ओहम के लिए. एंड यहाँ पे करंट का वैल्यू डायरेक्टली दिया हुआ है 5I0, वी आर टेकिंग एज इट इज, पॉजिटिव टू नेगेटिव है, वी विल टेक इट इज पॉजिटिव. फॉर 4 ओहम ओनली I3 is going and it is having clockwise direction positive, so we can take plus 4I3. that will we will get these equations after solving KCL for this loop. यहाँ पे सिर्फ करंट है इसलिए हम KCL अप्लाई कर रहे हैं. यहाँ पे यदि वोल्टेज होता, रजिस्टर होता, वी कैन अप्लाई KVL KCL दोनों हम सुपरपोजिशन में अप्लाई कर सकते हैं. हमें यहाँ पे अननोन करंट डिराइव करना है बट हम एट अ टाइम ओनली वी विल कंसिडर वन वोल्टेज सोर्स एंड वी विल रिमूव रिमेनिंग वोल्टेज सोर्स. इफ यू सॉल्व दिस इक्वेशंस you will get value of IO because of 20 volt, ये 20 volt की वजह से 52/17 ampere, 52/17 ampere. We will see if we are considering here the 4A ampere source, ये जो यहाँ का दिया था, we are considering this 4A ampere source. What we will do, we will remove this, we are removing 4 ampere. यहाँ पे क्या है, हाँ, वी आर रिमूविंग 4 एम्पियर एंड वी आर कंसिडरिंग 20 वोल्ट. हमने यहाँ पे पहले क्या किया, 20 वोल्ट को शॉर्ट किया था और हम ये 4 एम्पियर को कंसिडर कर रहे थे और यहाँ तो वैल्यू हमें पता ही नहीं है, अननोन है, तो हम ये दोनों को ही कंसिडर करेंगे ना, क्योंकि हमको ये दोनों की वैल्यूज पता है. यहाँ पे वोल्टेज सोर्स था तो मैंने शॉर्ट किया था, अब करंट सोर्स है तो मैं उसको क्या करूँगी, ओपन कर दूंगी और ये 4 एम्पियर की वजह से कितना करंट फ्लो हो रहा है, I will try to solve. So what we are doing here, we will open this 4 ampere. Then for this loop and this loop we can write the equation. ये तो open है तो यहाँ पे तो zero current flow होगा. If you are writing equation for this loop, for loop 4, you can see here for loop 4, if you write 3 and 2, you will get these equations here 6 I4 because if you calculate these resistors are in parallel, तो तुम इसका इक्विवेलेंट रेजिस्टर निकाल लोगे और उसके बाद तुम डायरेक्टली इफ यू सॉल्व यू विल गेट 6 ओहम. तो मैंने डायरेक्टली 6 into I4 लिखा है इसकी जगह. ओके, देन इन 1 ohm here in 1 ohm you can write 1 or 1 नहीं भी लिखा तो there will be no matter. So we can write here 6I4 minus I5U minus यहाँ का वैल्यू हमें पता नहीं है but we are taking here clockwise direction. But यहाँ negative से positive, that's why we are taking here negative minus 5UIO. That will be according to KCL 0. Now for loop 5, if you write for loop 5, for this 1 ohm, you can write minus I4 because this is going outgoing. Then you can write here, if you solve this 4 and 5, this, if you are seeing these elements, these are in series 5 plus 4 plus 1, these are nothing but 10. ये सीरीज में हो जाएंगे, that's why I am taking here directly 10 I5. अब किसी को क्वेश्चन पड़ेगा कि मैम आप इसमें से तो I5 भी जा रहा है I4 भी, but we are taking equation only for I5. We are taking for I5 as well as I4, but I am writing here combinedly instead of individually. If ये लोग देखोगे तो यहाँ तो ओपन है इधर का सर्किट, तो ये सारे रेजिस्टर जो है सीरीज में हो जाएंगे, इसलिए मैंने उनका एक साथ I5 के लिए लिखा है. और I4 का मुझे किसके लिए लिखना है, ये 1 ohm के लिए, वो मैं लिख चुकी हूँ यहाँ पे. Then we are having the value of voltage and it is from negative to positive, that's why we are taking here minus 20. और फिर we have to write here 5I0, ये जो यहाँ का करंट है, यहाँ का वोल्टेज है. I0 unknown है, but यहाँ का voltage they have given 5I0 and the direction is from positive to negative, that's why we are taking here positive. यहाँ पे भी मैंने क्या किया है, ये 3, 2 ohm and 1 ohm, these are in series, so directly I can write here 6IR4, ये साथ में लिखा है. And for I5 ये सिर्फ 1 ohm से जा रहा है, so 1 into I5, that is nothing but I5, and I am writing this voltage as it is minus 5 of I0. If you solve these equations, you will get the value of IO because of this 20 volt, because of this 4 ampere current. 4 ampere करंट को हमने ओपन किया है, हमने 20 वोल्ट को कंसीडर किया है, तब हमें इतना करंट मिल रहा है. और हमने पहले क्या किया है, 20 वोल्ट को हमने शॉर्ट किया था, 4 एम्पियर की वजह से जितना करंट जा रहा था वी हैव कैलकुलेटेड. नाउ वी हैव टू ऐड दिस करंट, देन वी विल गेट द वैल्यू ऑफ टोटल करंट. Therefore I0 equal to I0 dash plus I0 double dash. पहले हमें जितना मिला था that is nothing but 52 upon 17. 52 upon 17 minus 60 upon 17 minus 8 upon 17 ampere. This is the output current which will flow, and we can calculate this by using superposition theorem. यदि यहाँ पे डिपेंडेंट है तो हम क्या करेंगे, उसको as it is लेंगे. There is no need to remove, but if there are independent source, we have to remove these sources. Power. The total power must be determined using total current, not by superposition. We will get value of current by taking the additions. Thank you. If anyone is facing any doubt, you can ask. I am taking your attendance. So superposition theorem does not apply for the power calculations. Power calculations will be proportional to the current square or a voltage square. We cannot use superposition